Hello everyone. Today we will be talking about thermal conductivity of a good conductor using Searle's apparatus. Here we have considered copper. We all know that it's a very good thermal conducting material. Heat always flows from a hotter to a colder object, but the way it travels depends upon many other parameters. The extent in which the material can conduct heat is quantified by something called as thermal conductivity. So let's look at the experimental setup on which this experiment can be carried out to determine the conductivity of copper material. The copper material here is taken in the form of a rod. One end of the material is connected to a hot source, the other is connected to a cold source. This is generally the tap water that we connect, and this can be a steam inlet, it can be an electrical heater, or a hot plate. Four different thermometers are kept at different positions of the copper rod. When we start the flow of heat at one end, as a function of time, the heat flows through the length of the copper, and at the end of the colder portion, we see that the temperature of the water slowly increases because it is absorbing the heat that is released by this copper rod. Over a period of time, the temperatures T1, T2, T3, T4 thermometers, which are displayed, reaches a steady condition. Steady condition is a condition which is also called as thermodynamic equilibrium condition. This is a condition at which heat flow becomes constant. That is, heat absorbed by the material is equivalent to heat released by the material. Once the system reaches steady state, we can collect water from this water outlet, let's say for some time 5 minutes or for time 10 minutes. Once we collect the water, we have the formula here. M stands for the mass of the water that we have collected in a time of 5 minutes or 10 minutes. C is the specific heat of water, which we all know. L is the length of the rod. D is the diameter of the rod. Theta 1, theta 2, theta 3, and theta 4 are the corresponding temperatures that are noted in the four thermometers once a steady state is reached. So, after substituting all these values, we can calculate the value of thermal conductivity of a given good conductor. And the unit of the thermal conductivity is watt per meter Kelvin. Thank you so much. I hope you all understood how the Searle's apparatus